Okay, so I want to cover 12.3 and 12.4, which together are roughly this thing called graph transformation. The idea on these is roughly, I have a function that I know the graph of, like maybe f of x is x squared. And then there's some related function, like maybe g of x is minus x squared plus 2. And I feel like knowing the graph of f should help me figure out what the graph of g looks like, right? This should make a lot of sense. And there's just a bunch of rules that we're going to write down for these. So first things first are all this mess of rules. So there's vertical shifts. Okay? And for all of these, I'm going to assume that I've got a number, right? C, which is bigger than 0. And I'm going to assume I've got a function f that I know the graph of. That's cool with this. So these are going to be standing assumptions throughout these rules. So the vertical shifts are, okay, g of x is f of x plus a constant. Okay, so if I'm doing the function rule f, right, that kind of produces the graph for f, and then I add c to the outputs. That should kind of push everything up, right? And in fact, it does. So this is f shifted up by c units. Cool with that? So that's adding a positive constant. What if I had g of x was f of x minus c?
Shifts that way?
Yeah, that should shift the other way, right? Like down. So that's f shifted down by c units. You guys cool with these? One thing you could think is something like after the rule, adding shifts up, maybe. Okay? So this is vertical shifts, horizontal shifts. Okay, these are g of x is f of x plus c. You guys see the difference between these? Yeah, it's really, am I doing the rule f and then adding c, or am I adding c and then doing the rule f, right? So these are happening after I did the rule that I know the graph of. These are going to happen before, right? So if I draw a bubble diagram, these will come before the rule I know. These ones will come after. Horizontal things in general happen before the rule I know. Vertical things will happen after.
You do x before you do y.
Yeah, really, because I'm saying, is this happening to the x's that I plug into the rule? Like, is this an input thing, or is this an output thing?
Okay.
You guys see that? These guys, the ones that happen after, those are going to manipulate the outputs, right? So those are going to do things vertically. These ones are going to manipulate the inputs, so they'll do stuff horizontally. So this f of x plus c, that's going to be f shifted and this is the thing that you have to remember, there's no frickin' justice in the world, because you feel like it should be right, but it's left. Everything that happens beforehand is a little bit backwards. That'll happen when we do multiplication too. So keep that in mind. It's just opposite of the other one. So on the other one, it shifts up, which makes sense. And before it shifts down, well, not down, but left, which doesn't make sense. So that's left by C units. If I wanted to shift right by C units, what would I write? I'd write g of x is f of
X minus C.
perfect, x minus c. And that'd be f shifts right by c units. Cool? Okay, so those are my shifts. Then there's flips. Okay, so I'm going to write down vertical flip here. But we should think about what a vertical flip means. What's that flipping across?
Y-axis?
So vertical flip would be this one, right?
Oh, so X.
Which is flipping over the x-axis. Okay, so if I want to do vertical things, I should do it after the function, right? So this should be g of x is something done to f of x. How do I flip y's over?
Will you multiply it?
I multiply by
Positive? Negative?
-1. Right, I want to exchange the positive y's that are kind of up here for the negative y's that are down here, right? So I just swap the negatives for the positives. That'll flip everything over. So that's a g of x is minus f of x. I could think about this as maybe -1 times f of x, right? You guys see that? Okay, how about a horizontal flip? What should that be, across or over?
That'll be across the y-axis.
Yeah, that'll be across the y-axis. And how should I do that? That should be g of x is, to do horizontal things, it's got to happen
After.
before the function rule, right? It's an input thing I'm messing with. And I want to switch the negative inputs for the positive ones. So what do I do? What do I put into f?
Negative x.
Negative x. You guys see that? Cool. So these are the two flips. And then I'm only going to teach you one stretch because the other one's really kind of complicated and a little bit hard to comprehend. Cool? So we're going to do vertical stretches. Okay. So let me think. If I want to stretch everything out, I should what?
Multiply everything.
Yeah, I should multiply the outputs by something, right? That'll stretch this way. There is a way to stretch this way or compress this way, but it's really confusing, so we're just not going to do it. Cool? Your book decided not to. So I want to multiply the outputs, right? So I should take a look at g of x is some constant times f of x. Cool? Now the thing that's going to matter here is sometimes this is going to be a stretch by a factor of c, and sometimes it's going to be a compress by a factor of c. When's it a stretch and when's it a compress?
It would be a stretch when it's larger than 1 and a compress when it's smaller than 1.
Perfect. Yeah, when it's bigger than 1, it has a tendency to expand stuff, right? So I would call that a stretch. So that's happening for C's are bigger than 1. And then it's a compress for C's between 0 and 1. And what do I do when it's negative? Yeah, I think about it as a flip and a stretch. You guys cool with that? So these are all the rules that I want you to know. If you want to know the horizontal stretching rules, it's the exact same thing, but you swap the stretch and compress, right? Because there's no justice in the world. Cool? All right, let's try some examples, because we can actually do some examples here. So let's start with a graph of a function I know, like x squared. Okay, so I'm going to graph or sketch graphs of the following kind of stuff. So how about f of x is x squared? Can I graph that? What's x squared look like? It's like a parabola. Okay, so maybe here's f of x is x squared, right? I should put a point maybe on here for reference. So we know it goes through 0, 0. What's another point I know x squared goes to? Wow. Yeah, 1, 1. How do I know 1, 1's on there?
Because 1 squared is 1.
Yeah, good, because when I input 1, right, I get 1 out as an output. You guys cool with that?
Awesome.
Okay, so how about, say, g of x is minus x squared. What's that guy look like? Which rule am I doing?
Same one, but you flip it.
Okay, this is a multiplication by 1. Now is it a flip this way or a flip that way?
Flip that way.
Why?
Because it's a negative.
Because it's a negative? The other one would be a negative too.
Because it happens inside the function, not outside of it.
Other way around. This negative happens after I do the function, right? The function I know about is x squared. If I was drawing a kind of bubble diagram, right, I'd square first, then multiply by negative 1, right? You guys see that? So the fact that it's happening after my square means that it's a vertical thing. So it's a vertical flip. How about my marked point? Where did 1, 1 go to after I flipped it over?
1, negative 1.
1, negative 1. And then I can check and make sure that's on there, right? If I plug 1 in here, I do indeed get negative 1 out, right? You guys see that? All right. How about h of x is x squared plus 2, and w of x is x plus 2 squared. What's the difference between these two?
Well, in one square it's just on the x, and the other x squared is on the whole thing.
Yeah, so as function diagrams, right? This guy is what first and what second?
Add 2 and then square it.
Good. This one's add 2, then square. This guy is
Square, then add 2.
square, then add 2. So this one happening after means that it's a,
Vertical shift.
yeah, this is a vertical shift. That one's a horizontal shift because it's happening beforehand, right? This guy is manipulating the y's. That one's manipulating the x's. Cool? So what do they look like?
Just a parabola at 0, 2.
Yeah, that one's a parabola shifted up 2 units. So that's the same parabola as that one, which I'm not doing a great job of drawing. And this point is now 0, 2. Where'd my other marked point? Where'd that end up?
1, 3.
1, 3. Very nice. All right, that's just adding 1 to all the y values. How about the w? Where's that guy?
-2, 0.
Okay, so negative 2 zeros on there. How'd you know that?
So you have to do the opposite of what it's telling you, so you have to shift it left.
Yeah, I would think that's a right shift, but there's no justice in the world, so it's a left shift by 2 units. And otherwise, it's that same parabola. Where'd my other marked point go?
-1,
Yeah, that's at negative 1, 1. That's subtracting 2 from all the x values on my picture. You see that? Cool. Try some more. Okay, now I'm going to erase the rules. So everybody got these written down?
I remember that I got it written down, so.
Oh, we should do the one that I initially teased this with. So remember, we initially teased this with minus x squared plus 2, right? Okay, so on the more complicated ones, I definitely recommend drawing one of the little function bubbles. So this thing as a function starts with what? It's the first thing I do to an x in here.
Square it.
Square it. Okay, then what?
Multiply by -1.
Switch the sign, right? Multiply by -1. Then what?
Add 2.
Then add 2. Okay, so if I wrote these out as kind of function-y things, this is the one I know about. Right, so I don't need to do anything to this. This -1 is a which kind of flip?
Vertical.
You guys see that? It's after the function, so it's a vertical flip. How about the +2? What's that?
It's shifting it.
Shifting it, and it's up or sideways? Why is it up, Patricia?
Not sure.
Okay, good. So it's happening after the function rule that I know about, right? The rule that I knew about was squaring. So now after that's done, we're talking about y's. And so I'm talking about changing the y's by 2. That's a vertical shift up, right? This is up 2. You guys see this? So if I wanted to draw a picture of this thing, I could start with my usual parabola, right? So here's what I'm thinking, right? I start with my usual parabola, and then I need to vertically flip it. So I swap the positive and negative x, or negative positive y's. So that'll give me something like this, right? This is the worst sketch ever, yeah? And then what do I do to it? Shift it up 2. Okay, so it's going to look like this, right? And I could keep track of a couple of points on here, or I could just put them on at the end. So let's see, I know it should look like this, right? Where's this guy and one other point?
That is 0, 2.
Okay, that's at 0, 2, and any other point on here. I just want one more point to kind of anchor things out. So what's another point I could put on here?
Would you still have 1, 1? Because when you flip it, you have negative 1, 1, and then when you add 2, you go back to 1, 1, wouldn't it?
I think it would. Okay, so we think 1, 1's on there, right? How could we check?
And put 1 and see if you get 1 out.
Yeah, okay, so if I put 1 in, I square it, I get 1. Put a negative on it, that's negative 1. Add 2, I get 1. Oh yeah, it's still on there. You guys see that? Cool. All right, easy peasy, right?
So if you wanted to do a horizontal flip on that, you would go x to the negative 2? Or is that wrong?
That's not quite right.
Okay.
I'd want to multiply the x by negative 1 before I started, right? So let's make one with a horizontal flip.
Okay.
So how would the bubble diagram go for a horizontal flip using x squared?
Negative 1.
Okay, so I'd multiply by negative 1, and then I'd square, right? Okay, so if I was going to write down a formula for this thing, I might call it, I don't know, m of x, because it was Matt's idea, right?
Why me?
It was your idea. So what's a formula for this? I start with an x, right?
Yeah.
And then I...
So it'd be, so it would just put the negative inside parentheses with the x?
Yeah, so I do negative x, and then I need to square that whole business, right? What's negative x squared?
Positive.
Oh, yeah, this is the same thing as x squared, right?
Yeah.
What's happening there?
Yeah.
Here's x squared, right?
Mm-hmm.
What happens if you do a horizontal flip?
Nothing.
Nothing. So of course it's the same, right? It should be.
Yeah, but for cube root it would be different.
Yeah, for cube root it'd be different. So if we cubed it instead, right? The only thing that's going to change are these guys, right? And my picture, of course. Oops. That guy's wrong. It's no longer true. Okay, so what's x cubed look like? Yeah, it looks like a whoopie. Oops, crappy drawing. Ah, it was going to be a crappy drawing anyway. It's a really crappy drawing, but it looks like that thing-ish. Now I want to do a horizontal flip on that thing, so what's it going to look like?
Just the other quadrants have line.
Something like that?
Yeah.
All right, let me draw another color on here of what we started with there. We started with the purple, right? This was x cubed. And then this thing is minus x cubed. Okay, see that? This was our m of x. And if I wanted to give that thing a function label, I might call it f because it's the one I know about. What's weird about this one?
You make a parabola.
Yeah, it almost makes a parabola. It's not quite, but almost.
Yeah.
What's the other weird thing? The horizontal flip looks a lot like a vertical flip, doesn't it?
Oh yeah.
You guys see that? Why is that? Well, it's negative x cubed. It's another way to write that.
The third root of negative x?
Not third root.
What third root?
Oh.
Cube root.
I could write this as negative 1 cubed times x cubed, right? What's negative 1 cubed?
negative 9.
That's horizontal flip is vertical flip. You guys see that? They're algebraically the same thing, so they must be graphically the same thing for this function. This is actually kind of a cool thing that we use to find symmetries in functions. Functions with the property vertical flip is horizontal flip are called odd. Functions with the property horizontal flip doesn't do anything are called even.
Okay.
You've discovered something very cool. You guys want to see another weird one with flipping? Sure. All right, let's try a function that's neither even nor odd and see if we can straighten out some flips on it. So we don't know so many graphs of functions, right? But there's one more we know that's neither even nor odd. It's f of x is the square root of x. What does this thing look like?
It's like kind of like that, but flatter, a lot flatter. And
Kind of like this?
yeah, it's like not like that one, like the
It's a little bit like cube root, but kind of flatter and only half of it, right?
Yes.
It's half a parabola. Did you guys ever get that connection? Remember from the inverse functions thing? If I want to find the inverse function, I should flip it over y equals x, right? So if I take a parabola and I flip it over y equals x, it looks like a parabola but sideways. And it's not a function anymore, so I drop the bottom half to make it a function. So I get a picture that looks like this, roughly. Here's your f of x is square root of x. Okay. How do I get this one? Let's call this one g of x. Is that a horizontal or a vertical flip?
horizontal.
See that? That's the one over the or over the y-axis, so that's a horizontal flip. So that's g of x is
The square root of negative x.
square root of negative x. Okay. Your head's all straight for a second. See if we can twist them a little bit. How about this guy? Call this one h of x. What's that one?
The negative square root of x.
Negative square root of x. Right? These are root x and minus root x. That's plus or minus square root of x, right?
Negative square root of negative x.
Ah, very good. Everybody seems to happen across that eventually. There's an obvious hole in my picture, right? That's this one. Red marker sucks. And we should call that one w of x because it's really weird. And that's what now?
Negative square root of negative x.
Good. That's negative root minus x. Right, and I think about that as a horizontal flip first to the purple, then a vertical flip to the red. You guys see that? That one's sort of fundamentally confusing.